My name is Salma. I'm CEO and one of co-founders here at Sifflet. And I'm here today to discuss how data integration and data observability are better together. And as you can see here, Octavia seems very excited about our session, so let's get to it. So first of all, before we get into our topic, let's define what data observability is and why it's something that any data practitioner today should care about. As I'm sure a lot of you in the audience know or heard, data observability is a concept that comes from software, and before that from control theory. And in software, observability is the ability to define the health status of infrastructure and applications by looking at the outputs produced by the system. And the idea is to ensure continuity of the service and then to get ahead of application downtime. Observability in data is a relatively new category, and the idea is fairly similar. So we want to observe and monitor different outputs about the data, the metadata, the pipelines, etc., to get a holistic overview of how these assets connect to each other, and more importantly, get ahead of data incidents or data quality issues. So data observability focuses on 3 or 4 main pillars: metrics and logs, metadata, and lineage. For the sake of today's presentation, we want to focus on certain metrics that are relevant in the case or the use case of data integration and data ingestion, and more specifically about how you can monitor and observe the data at the source. So let's look at some of the metrics that will be useful for today's session. So for data quality metrics, at the data level, you want to look at the accuracy of the data assets. You want to look at format validation. You want to do data profiling. You want to look at statistic outliers, nulls, etc. You want to look at some metrics at the metadata level. Is the data up to date, or what we call freshness? Am I ingesting the right volume? Is the schema or the format and shape of data objects in the expected shape, the distribution of the data assets, etc. You also want to look at the logs of different applications that the data runs through, namely, the ingestion layer, the transformation, the modeling, the orchestration, etc., to know how certain anomalies at the infrastructure layer might lead to data quality issues and how you can get ahead of that. So what we call here at Sifflet full data stack observability is essentially a top of stack layer. So we come and sit on top of your existing data stack. We have connectors that go from data source all the way to destination. It covers the ingestion layer, the transformation and modeling, warehousing, BI analytics, reverse ETL, machine learning, etc. And more importantly, the glue that holds everything together through the orchestrator. And the idea is to provide both data producers and data consumers with insights that make sense to them, and that can help them better understand their data assets and get a good idea of the health status of their data assets and ensure reliability of them. Now let's get to the topic of today, data observability and data integration, and how can you incorporate both processes at the same time to ensure that you're getting full potential out of both tools that you're using for observability and integration. So in order to or practically speaking, how are you going to go about incorporating observability and data integration or data ingestion at the same time? The idea here is to not only monitor the data that you are ingesting, but also monitor the robustness of the ingestion process itself. So practically speaking, you want to monitor that the connectors are loading the large volume of data, that the data ingestion is happening at the schedule that you were expecting it to happen to, and that you have a bird's eye view of everything that's being ingested from the sources. And you want to set up checks at 3 main levels. So first of all, you want to set up what we call table level metrics, things like row counts, volume, freshness, etc. And you can you do this using some existing fantastic open source solutions for data quality monitoring, or you can use something that we call it Sifflet data observability as code, and you can incorporate that really in the way you're building the connector on Airbyte, for example. The second layer you want to look at is column level metrics. So you want to go a bit deeper into the data assets and kind of predict any deviation from expectation. And here you can set up checks to look for null, duplication, low cardinality fields, outliers, etc. And finally, and this is the most crucial part, you want to set up pipeline level metrics to make sure that your ingestion process is actually robust, because it doesn't matter if you're keeping an eye on the quality of the data assets that you're ingesting. That's actually better than nothing. But more importantly, you want to make sure that your ingestion process is not breaking and that actually the pipelines are performing in the way you expect them to perform. And here we can look at metrics such as run state, run duration, and see if there is any anomalies there, anything that's deviating from normal highly performing behavior. You want to look at compute time, etc. Once you have set up all these checks and metrics using a data observability solution like Sifflet, or using open source or whatever that may be, the next step, and this is very important to improve that everybody's working together around ensuring reliability of the data assets and data infrastructure, is to assign ownership. And this is a big topic because you don't want to leave, or you don't want to exacerbate the effect that data silos can have on the how data and trusting data gets eroded in the system. And so you want to assign owners to data assets, and you want to assign owners to data quality checks so that everybody's on the same page. And finally, you choose your favorite alerting system, whether that's you want to send alerts to Slack, to email, PagerDuty, Opsgenie, whatever that may be. So now let's look at what happens after the anomaly is detected, or after your observability framework, once you kind of marry it with your ingestion tool, and sends you alert when something is wrong. What do you do with those alerts? And this is where a very important pillar in observability comes into play, which is lineage. So by having full stack lineage, you're able to map out the dependencies between different data assets, between different views, different dashboards. But more importantly, you can also go into the application layer by connecting also the dependencies between jobs and different elements and components of the infrastructure that could lead into a deviation at the data and metadata layer. And here, if you want to go, this screenshot is from Sifflet, where you can see that the lineage is going all the way from Airbyte. So here we can see that there is a pipeline on Airbyte that's getting data from Salesforce, feeding into a table on Snowflake that's being modeled on dbt, and then back to Snowflake, and then it follows the whole workflow around the enterprise data pipeline. So by having this bird's eye view with the lineage, and by getting information from a tool like Airbyte on how we compute the lineage as well, we are able to pinpoint the data producer directly to the root cause whenever there is an anomaly that's detected. So that helps with efficient troubleshooting. It helps create a more automated root cause analysis mechanism, and it helps save time for data producers. At the same time, data consumers want to be aware of how incidents are likely to propagate and how they're likely to impact their own workflows and dashboards around data. And so it is good to know where the problem is coming from, but you also want to know how it's likely to propagate. So that's also one of the very powerful use cases of data lineage in this case. Now, to circle back on everything that we said, once you have successfully implemented data observability and data integration, or data observability within your data integration process, you'll hopefully get to a place where you can move data reliably, no pun intended. And some of the key results that folks who've adopted similar processes, and some of the customers that we work with have seen, are improvements in time to detection, time to resolution for data incidents, particularly when you have that full stack lineage, ability to capture and follow the data flow from source to destination, which can be extremely crucial in a world where data sources are only getting larger and multiplying in number. You can finally have better definition and adoption around SLAs, SLOs, and SLIs within the data team. And more importantly, you can actually improve not only the robustness and the reliability of the data asset, but also the data platform and the data experience for data practitioners, and reduce what we call at Sifflet data entropy. So this is it for my session. If anybody has any questions, feel free to contact me. either on LinkedIn or Twitter. I'm at Salma Babkouk, or send me an email, salma@siffletdata.com. I'll be more than happy to go into more details about what I mentioned today. And thank you so much for your time.